Hi, today I'm going to show you how to solve a normal distribution problem. I will read to you the problem that we're going to solve. Is lack of sleep causing traffic fatalities? A study conducted under the auspices of the National Highway Traffic Safety Administration found that the average number of fatal crashes caused by drowsy drivers each year was 1,550. So we know mu is equal to 1,550. Assume the annual number of fatal crashes per year is normally distributed with a standard deviation of 300. So we know sigma is 300. Question 1 is asking what is the probability of fewer than 1,000 fatal crashes in a year? The way to solve these problems is always draw a little normal curve for yourself, a little key. Mark the center on the x-axis with what the mean is for the distribution. In this case, it's 1,550. And always write the standard deviation somewhere close by. Now, in this problem, the first part, we're going to find out what is the probability of fewer than 1,000 fatalities. So on the number scale, find a place where it would be equivalent to 1,000, which would be to the left of the mean. And we want to know fewer than 1,000 fatalities. Shade the area that you're after. In this case, it would be this area, fewer than 1,000. Now, we need to convert this to the z scale. The 1550 on the z-axis would be 0. The mean on the z-scale is always 0. Let's find out the equivalent of the 1,000 on the z-scale. Z in this case would be 1,000. We know that the z formula is x minus mu over sigma. So 1,000 minus 1,550 divided by 300 gives us negative 550 over 300, which is equal to negative 1.83. So we need to go here. I'll write it. Negative 1.83 would be equivalent to the 1,000 on the z-axis. Now we need to go to the normal distribution. On the z-axis, we find 1.8. And then we go across the top to find 0.03. At the intersection, you're going to see 0.0336. 0.0336. Now let's understand this table. The z-axis or the z numbers are described in the left column and the top row. The integer and the first decimal point, which would be the negative 1.8, can be found on the left side or the left column, and the second decimal in the z value, which in this case would be the 0.03, can be found across the top. And we know that because we know negative 1.80 minus 0.03 gives us negative 1.83. And so that's how we read it on this table. Now at the intersection, we find 0.0336, which is what I marked here. Therefore, the answer to our question is probability that x, or a number of fatalities, would be less than or equal to 1,000 is equal to probability that z would be less than or equal to negative 1.83, and that answer would be 0.0336. And I will highlight that for you, and that's the answer to this question. Now keep in mind that whether we had asked what is the probability that the number of fatalities was less than 1,000 or less than or equal to 1,000, you would have exactly the same answer, because the normal distribution is a continuous distribution, and the probability for an exact value of x of the random variable equals 0. So whether you say probability that x is less than 1,000, or that would be the same as probability that x is less than or equal to 1,000. And the reason for that is because with a continuous distribution, that would be the exponential distribution and normal distribution that we will study, the probability of an exact value is equal to 0. So the probability of the random variable being exactly 1,000 is 0, therefore it doesn't make a difference in how you write this. So that's the first part of this problem. Thank you.